Hello students. Today we are going to discuss about the production of rotating magnetic field in a three-phase AC machines. So in a three-phase AC machines, when three-phase terminals are connected to a balanced three-phase supply, the magnetic field or magnetic flux produced by each of the phase winding is of pulsating nature, which pulsates about the quadrature of the phase axis. But the resultant of these magnetic flux, resultant of all the three magnetic flux, is of rotating nature, which rotates in space with constant speed, which is synchronous speed, and the magnitude of this resultant flux is constant. The direction of rotation can be found by obtaining the phase sequence, and the speed can be found by knowing the value of supply frequency and also the number of poles. So we will analyze the nature of a rotating magnetic field analytically as well as graphically. First of all, the instantaneous value of flux produced by all the three phases can be written as phi r is equal to phi m sine omega t or phi m sine theta. Phi y is equal to phi m sine omega t minus 120 degree, means flux produced by yellow phase lags behind the red phase flux by 120 degree. And also the flux produced by blue phases lags behind the flux produced by the yellow phase by 120 degree. And also there is a angular displacement of the corresponding phases, means red phase, yellow phase, and blue phase, which is also of 120 degree, means the axis r dash and y dash differs by 120 degree, and also y dash and blue dash differs by 120 degree. Means if we consider the red phase, then for positive half cycle R dash, for positive half cycle, the direction of current will be inward from the upper coil side, and outward through the lower coil side. But for negative half cycle, the direction of current will revert. So therefore, for negative half cycle, current will enter through lower coil side and current will be in outward direction from the upper coil side. So the direction of magnetic flux produced by a red phase will also revert. Means for positive half cycle, the direction of magnetic flux will be in leftward direction, which can be found by using right hand thumb rule. Right hand thumb rule. And for negative half cycle, the direction of magnetic flux will be in the rightward direction. And the same phenomena will work for all the remaining two phases. So we will analyze, we will determine the nature of the rotating magnetic field by considering the response at three different instants. Means we will analyze the resultant magnetic field at theta is equal to 0 degree, theta is equal to 60 degree, theta is equal to 120 degree. Means these three instants, 0 degree, 60 degree, 120 degree. And if we consider the case 1, instant 1, means at theta is equal to 0 degree. At this instant, If we substitute the value of theta in these equations, then we will get phi r is equal to 0, that is sine theta, sine 0 will be 0. And if we substitute theta is equal to 0 in equation 2, in expression 2, we will get phi y is of negative magnitude, that is 0.866 phi m. And similarly, phi v at this instant will be 0.866 phi m. So, if we draw the phasor diagram corresponding to these fluxes, so phi r is 0 and phi y represents signifies the negative value. It means the direction of current in yellow phase is reversed. So we will mark phi y is negative. So we will mark phi y here, it will be negative, and here it will be positive. Means current from this side will be in, sorry, in current from this side will be in inward direction, and here from outward direction, dot. Similarly, phi y is positive. It means the current, this terminal, this coil side, the current will flow in inward direction, and from this side current will flows out to the plane. So by using these convention, the flux produced by each of the phase can be found. So for yellow phase, phi y can be drawn here, which is perpendicular to the phase axis, and with direction can be found by using right hand thumb rule. And similarly, phi b can also be found. So, and the phi r is 0. So the resultant flux, that is total flux phi t, will be the resultant of these two flux phi y and phi b. Magnitude can be found simply by phi t is equal to under root of phi y square plus phi b square plus 2 phi y phi b into cos of theta. Theta is nothing but the angular difference, that is 60 degree in this case. So cos 60. So the resultant phi t will become, that is 1.5 times phi m, which is of constant value. So we can say that in this case, at theta is equal to 0, at this instant, the resultant flux will lie vertically downward. Now, if we consider the second instant, which is theta is equal to 60 degree, in this case, all the three phase fluxes phi r will become, if we substitute theta is equal to 60 degree in these three expression, we will get phi r is equal to 0.866 phi m, phi y is equal to minus 0.866 phi m, and phi v will become 0. So here phi v will be 0, and if we draw the phasor corresponding to red phase flux and yellow phase flux, so phi r is positive. It means here current will be inward, and from this side current will be outward. So we can draw the phi r, that is the flux produced by red phase along this direction by using right hand thumb rule. And similarly, phi y is negative, so we can say that in this case, so phi y in this case, the inward current through this coil side, this coil side, and from this coil side, the current will flow through into the outward direction. And we can say that the phi y will be perpendicular to the phase axis. We can draw here. So the total flux will be in this direction. Again, the phase difference, angular difference between these two flux will be 60 degree. And by using the same formula, we can determine the total flux will become 1.5 times phi m, which is same as the previous case. And one more point to be noted, the resultant flux axis shifts by 60 degree. Now we will consider our last case, that is at instant theta is equal to 120 degree. If we substitute theta is equal to 120 degree in all these three expression, we will get phi r is equal to 0.8665 m, phi y will become 0, and phi v will be 0.8665 m of negative. So phi r is of positive value, then here current will be inward and here outward. And for blue phase, it is of negative sign. So current will be here inward and outward. So we can draw phi r and phi v by using by using right hand thumb rule. The total flux phi t can be found by using the standard formula, that is under root of x square plus y square plus 2xy cos theta. And theta in this case, again, same 60 degree. So the resultant again become 1.5 times phi. Magnitude is 1.5 times phi. From all these three cases, we have analyzed that if we take the different instant, that is theta is equal to 0 degree, theta is equal to 60 degree, theta is equal to 120 degree, the magnitude of the resultant flux is of constant value, but rotates at constant speed. So by analyzing these three cases, we can say that for each cycle that is of theta of 360 degree, the resultant magnetic field will complete one revolution. But this phenomena is applicable only for two-pole machine. If we consider a four-pole machine or six-pole machine, then one complete revolution will take place from number of cycles of the input supply. Means, let us consider a general case. Let us consider a machine with p number of pole. Let us say number of pole in the machine is p and ns is the revolution per minute. Means the number of revolution per minute by the magnetic field poles is ns. Then number of cycles per revolution is p by 2. Now focus on this point. For two-pole machine, it will be 1 for two-pole machine. Means number of cycles per revolution is equal to 1. That is only for two-pole machine. But if we consider four-pole machine, then number of cycles per revolution will be 2. Means in that case, the magnetic field will complete one revolution on the application of 2 cycles of the input supply. Number of cycles per revolution. For 6-pole machine, the magnetic field will complete one revolution on the application of 3 cycles of the input supply. So here, one more thing, revolution per second is given as ns upon 60. ns is revolution per minute. So now we will find a relation, that is frequency. For a p-pole machine, how can we relate number of poles, applied frequency, and the RPM? So frequency is nothing but the number of cycles per second. So number of cycles per second, that is number of cycles per revolution multiplied by revolutions per second. We can find number of cycles per second. So F equals to number of cycles per revolution for P pole machine, that is P by 2. Here P by 2, and revolution per second, that is NS by 60. By simplifying this expression, we will find speed of rotating magnetic field, that is NS is equal to 120 F upon P. It means for constant frequency, let us say if we consider 50 Hertz, if number of pole is increased, the speed will reduce. Speed will reduce. Same things can be obtained, same conclusion can be determined from this concept. Like I have told that if we increase the number of pole, then one complete revolution will take place after the application of more number of input cycles. Like as we increasing number of poles 4, 6, 8, 10, and so on, then time taken to complete one revolution will increase. Then we can say that same things can be same conclusion can be derived from this relation also. Like if we increase the number of poles, the speed will reduce, RPM will reduce. So from all these discussions so far, we can conclude that the rotating magnetic field produced by a balanced three-phase supply is of a rotating nature, which rotates in space with a constant speed, which is 120 F upon P. And this revolving magnetic field, rotating magnetic field, having a constant magnitude, which is 1.5 times phi. Thank you.